Write a SQL query. Select star from users where ID equals 42. Looks simple, right? But behind that one line, the database has to make a decision. Where is user 42? Out of millions of rows, how does it find the right one? The answer determines whether your query takes 1 millisecond or 500. Today I am showing you exactly how databases find your data and why senior developers care so much about indexes. Let's start with what happens when there is no index. The database has only one option: read every single row. Row 1, not user 42. Row 2, not user 42. Row 3, not user 42, and so on, until it finds the match or reaches the end of the table. This is called a full table scan. With 1,000 rows, it's fine. With 1,000,000 rows, it's painful. With 100 million rows, your application is dead. So how do we fix this? An index, specifically in most databases, a B-tree index. Think of an index like the index in the back of a book. Instead of reading every page to find the topic you want, you flip to the index, find the topic, and jump straight to the right page. A B-tree does the same thing for your database. It's a tree structure that lets the database find any row in just a handful of steps, no matter how big the table is. Here is how it works. The B-tree is sorted. The root node holds a small range of values. Each branch points to a deeper node with a smaller range. At the bottom, the leaf nodes point to the actual row data. So when we ask for user 42, the database starts at the root. Is 42 less than 100? Yes, go left. Less than 50? Yes, go left. Less than 45? Yes, go left. Found it. 3 comparisons, 3 jumps, done. A 1,000,000 row table with a B-tree index, maybe 4 comparisons. A 1,000,000,000 row table, maybe 6 comparisons. The performance is logarithmic. It barely cares how big your table gets. But indexes aren't magic. They only help when the database can use them. Where ID equals 42, index helps. Where name like %, index can't help. The wildcard at the start breaks it. Where age greater than 30 and name equals Dmitry. But you only have an index on name. Database might use the name index, then filter by age in memory, or it might decide a full scan is faster. The query planner makes the call. This is why you check your query plans. Explain in PostgreSQL, explain plan in Oracle. Every database has it. Run it, see what your query is actually doing. So indexes are amazing for reads, but they have a cost. Every time you insert a new row, the database has to update every index on that table. Same for update and delete. Indexes make write slower. A table with one well-chosen index, well, barely any cost. A table with 20 indexes just in case, your writes will call. The rule: index the columns you actually filter on, sort on, or join on. Don't index everything. Index strategically. So where it is. Without an index, the database checks every row. With one, it traverses a tiny tree and lands on your data in a few steps. This is why your senior devs say add an index every time you mention a slow query. They are not being lazy, they are remembering this picture in their head. If this helped, hit subscribe. Next Tuesday I'm explaining what actually happens when you run git push. See you then.